Welcome back, everyone. We are going to do the practice exam today. And here we go. There's only 21 problems. A census of all the 10,576 current students at the local community college showed that 57.2% want to transfer to a university. Their average age was 23.7 years, and 62 of them are pursuing degrees in mathematics. In order to attract more students, the math department organized an Opportunities in Mathematics fair for the current students of the college. A total of 258 students from those who attended responded to the poll. The poll showed that 82% who answered want to transfer to university. The average poll respondent was 21.6 years old, and 79 of them were interested in pursuing a degree in mathematics. All right. So which one is going to be the population? The population will always be all of them. The sample is literally the sample of 258 students. In part B, wants to know, and I want to show you how I'm coming to these conclusions. The 82% of students who responded to the poll who want to transfer to the university. Now, when we look up at the 82%, that's the sample poll. And so it says the poll. So that makes this a statistic. That means it's based on the sample. Let me check something. Okay. All right. So the 79 students interested in pursuing a math degree among the students who responded to the poll. Again, we're talking about the poll. So we're here. The average age of 23.7 years of, and here's the key to this one, of all current students. That's the trigger for us. That is going to mean that that number is a parameter. And I'm just going to go until someone stops me or has a question or wants me to go over something again or whatever. Number 2. So we're going to decide if it's quantitative, meaning are numbers involved, or is it categorical, where numbers are not involved. The temperature in degrees Fahrenheit, that is definitely quantitative. Dosage in milligrams of medication, again, also quantitative. Mother's occupation, that is definitely going to be categorical. Playing time in seconds of a DVD, that is going to be quantitative. Any questions there? All right. Oh, you know what? For some reason, this PDF, it repeats itself. I remember that. And occasionally some of the tables will be missing and things like that. I don't know why that happens. For each of the variables described below, indicate whether it is quantitative or categorical. Also, the level of measurement, nominal, ordinal, interval, or ratio. So here we go. Part A, the temperature in degrees Celsius. That is definitely quantitative. And because we're talking degrees Celsius, that's going to make it interval. There's no natural zero with that one. 2 degrees is not twice as hot as 1 degree. B, duration in minutes of a call to a customer support line. That is going to be quantitative. And that is going to be ratio because there is a natural zero and one call could be twice as long as the other, meaning there's meaningful ratios. Part C, medal won in a recent race, gold, silver, bronze. That's going to be categorical. And the order super matters. That makes it ordinal. Now we're going to see the difference between discrete and continuous. The time that a student in Introduction to Calculus takes to complete the midterm exam. That is definitely continuous. Now remember, there's a difference between countable and measurable. Something can be measurable but not countable, like time. It's exactly not countable. The cranial capacity, space inside of the skull of a human skull. That is also going to be continuous. The length of the arm of a heavyweight boxer. That is also continuous. Now, the number of children in a household, that is countable. That is discrete. Lincoln High wants to estimate the number of students who drive to school. Answer the following. Which of the following surveys probably would best represent the entire student population? 25 students were randomly selected from the 10th grade, 3 drive to school. Doesn't say anything about 10th grade. 25 students were randomly selected from the school, and 6 drive to school. That's looking good to me. And the last one talks about the science club. That certainly has nothing to do with all of the students. Now, this is the one that we have a little bit of math that we're going to have to do with this one. This says that 6 out of the 25, if we can get a percent from that, 6 divided by 25. So that gives us 24%. And if there's 1,650 students at Lincoln High, use the answer for part A, meaning the percent that I got there on the right. Estimate the number of students who drive to school. Well, this is going to be 24% of 1,650. So that looks like that's going to be 396 students. So 396. We okay there? All right, so now we have how to get a how to collect data. Part A, a consultant wants to ask workers at a factory about the workers' job satisfaction. Which of the following best describes a random sample of workers? The first one, all of the workers on the second floor in the factory building are easily accessible. So the consultant selects the first 64 workers. That's convenient sampling, right? We want to avoid that. Second one, the consultant forms groups of 8 workers based on the lengths the time the workers have worked at the factory. Then he randomly chooses 8 groups and selects all the workers of the groups. That's called cluster sampling. The third one, the consultant assigns each worker a different number. Using a random number table, he draws 64 of those numbers at random. Then the consultant selects the workers assigned to the drawn numbers. Every set of 64 workers is equally likely to be drawn. That is, by definition, a random sample. There it is. Part B. A manager at a bus company wants to survey employees about the new uniforms. Which of the following best describes a stratified sample of employees? The manager forms 4 groups of employees based on the departments the employees are in. Then she selects 20 employees at random from each group. That is exactly stratified. All right. Part C. A host on a cruise ship wants to collect data on the time passengers spend at various activities on board. Which of the following best describes a convenience sample of passengers? The host forms 6 groups of passengers based on the level of the ships that the passenger cabins are on. Then he selects 9 passengers from each one. No, that's stratified. Second one, the host takes a list of the passengers and selects every 6th. That's not it either. The host selects the first 54 passengers who board because these passengers are easily accessible. That is convenience. All right. So to do this next one, I need to use my list. So I'm going to go to Stat, Edit, and I'm going to clear my list 1 and put in my values. So let's read the question real quick. Miss Russell gave her students a biology test last week. Here are the test scores for each of the 11 students. Complete the group frequency distribution for the data. All right, and note that our class width is 6. So 70. All right, and I'm going to quit. And now I'm going to sort. So I hit Stat, Sort A. And I know I'm going to get a commercial on this free cell phone, so if I do, I apologize. Second one. All right, so now I'm going to go back into my list. And how many of these are between 66 and 71? I'm seeing 1, 2, 3. Between 72 and 77, I see 1, 2, just 2. Two. There we go. From 78 to 83. So 1, 2, 3, 4, 5. Ooh. And from 84 to 89, there's just 1. Now I'm going to quit out of this. And when I add this up, I should have 11. So 3 plus 2 plus 5 plus 1 is 11. So that's how I know I got all of them in. All right. All right, so for this one, I am going to have to put the data in the calculator for a second, but I want to handle the labels. It says to start at 21.5, and there's 5 classes. So to find the class width, this is going to be 46.5 minus 21.5 divided by 5. So my class width is 5. So I'm going to take 21.5 and I'm going to add 5 to that. And I'm going to add 5 to that. I'm going to add 5 to that. Add 5 to that. And that gives me 1, 2, 3, and 4. Now it says that it needs 5, so I'm going to add 1. So plus 5 again. So this is 46.5. All right, and I'm going to put all of this data into my list. Ugh, annoying. Yeah, I don't see an option to fast forward. Sorry, this is one of the long ones. Come on. There we go. Okay. So let's clear this. And let's just start putting the data in 26. Um, 43. All right, so let's quit out of that. Second quit. Sort. All right, so let's see what we have. From 22 to 26, I have 1, 2, 3, 4. So 1, 2, 3, 4. I apologize for my bad handwriting. From 27 to 31, 1, 2, 3. And from 32 to 36, looks like 2. And from 37 to 41, 1, 2, 3, 4, 5, 6, 7. Wow. 7. So all the way up here. And from 42 to 46, 42 to 46. So that's 1, 2, 3, 4, 5. I'm seeing 5. Yeah. So 5. So that's going to be here. It's pretty ugly, but it is what it is. So that's really bad. Let's move on from there. All right, let's move on to number 8. Number 8. Okay. So the Reyesberg Corporation is contemplating using a new glue in the construction of its laminated veneer lumber. Of importance to the company is the carrying load of the lumber. The company tested 25 beams while using the new glue, recording for each beam the pressure, pounds per square foot, at which the beam broke. The data collected are presented in the following histogram. Based on the histogram, find the proportion of carrying loads in the sample that are greater than or equal to 880 pounds. So 880 is here. That's my cutoff. And first of all, I need to know what the total is. So I need to know 5 plus 5 plus 8 plus 4 plus 3. That's my denominator. And how many of them are more than 880? Greater than or equal to 880? Well, that looks like it's going to be 5 plus 8 plus 4 plus 3. This is 20 over 25. So it looks like 80%. They want it as a decimal. Draw the line plot for these numbers. I called it a dot plot in the notes. So let's see, we'll start with 7, 9, 6, 6, 9, 9, 5, 8, 8, and 6. There we are. All right, we are moving on to number 11. All right, now we could put this into a list and use one var stats, but I'm going to do it the old-fashioned way, just to remind us how to do that. So we add everything up, 9 plus 4 plus 3 plus 9 plus 7 plus 10 plus 4 plus 7. Ah, damn it. 9 plus 4 plus 3 plus 9 plus 7. So I got 53, and there are a total of 8 people, so divided by 8. So X bar is the mean. It says round to the nearest tenth. So this is 6.6 minutes. All right, so that is our answer. On to number 12. So we want the median. So I am going to put this into a list for us. Remember to clear your list every time. All right, so we're finding the median. So I'm going to quit out of this and run one var stats. That's under stat. Calculate one var stats on list 1. And there's our median right there. It looks like it is 9. And number 13, remember, they're looking for the mode. And remember, the mode is the most repeated number. Let's see if we even have one. No other 14s, no other 22s, no 17s, no other 24s, 19, 18, no, there's no mode. That's easy. All right. Number 14, petroleum pollution in oceans stimulates the growth in certain bacteria. An assessment of this growth has been made by counting the bacteria in each of 5 randomly chosen specimens of ocean water. The 5 counts obtained are as follows, and they want us to find the standard deviation. So I'm going to put that in a list again. So 66, 58, 68, 46, 42. All right, let's run one bar stats, second quit. Stat, calculate one of our stats. And standard deviation is our SX. There it is. And they say rounded to 2 decimal places. So our sample standard deviation is about 11.66. All right, we are getting there. All right. The lengths of movie files that are available for streaming are modeled using a normal distribution shown below. The mean of the distribution is 189.7. Now I'm going to put that here. 189.7. The standard deviation is 20.2. In the figure, okay, so we need to find U and W, and we need to find out if we go one standard deviation away, it's 68% up top. If we go two standard deviations away, it's going to be 95%. And if we go three standard deviations away, it's 99.7%. That's the empirical rule. So I'm going to go 189.7, and I'm going to add a standard deviation to it. And 209.9 is between 200 and 220. So 209.9. And that is exactly one standard deviation. Now let's go the other way. 189.7 minus 20.2. And 169.5 is in between, so we're only one standard deviation away. Oops. And once again, this is exactly one standard deviation away. Which means for us, our answer is at 68%. Ravi works for a customer advocacy agency. He wants to test the claims made by the manufacturer regarding the lifetime of certain brand of all-season automobile tire. The lifetime is the distance the tires last until it needs to be replaced. Okay. He chooses a random sample of 10 of the tires to test. He finds that the sample mean for the lifetime of these tires is 80,954 kilometers with a sample standard deviation of 5,115 kilometers. According to the claims made by the manufacturer, the lifetimes of this brand of all-season automobile tire have a population mean of 81,123 kilometers and a population standard deviation of 4,126 kilometers. Now, our goal for this one is to find the proper symbol to use. So for the first one, they're saying the population standard deviation is going to be right here. It's that sigma. The sample mean is going to be X bar. And the sample standard deviation is just going to be the S. All right, next up. The local aquarium houses sharks of various species. At the aquarium, Chico is an adult male shark that is 3.9 meters long, and Emma is an adult female shark that is 4.2 meters long. The distribution of the lengths of adult female sharks in the aquarium are clearly bell-shaped. The same is true for the male. The aquarium's adult female shark population has a mean length of 3.74 meters and a standard deviation of 0.19. The aquarium's adult male shark mean length is 3.69, a standard deviation of 0.13 meters. So let's find Chico's length. So we're going to go Z, or not the length, the Z score. And we're going to take Chico's length, that's 3.9, and we're going to subtract the mean. Chico's the male, yeah. And so the male is 3.69 divided by 0.13. So I'm getting about, Chico's z-score is about 1 point, and do they say where to round it? Round to 2 decimal places, okay. So I'm getting 1.62 for Chico, and for, I forget the female's name, Emma, we're gonna go 4.2. Oh, I need to write down z equals 4.2. And the female, here, let's get too crowded. So she is 4.2 minus the female mean, which is 3.74 divided by 0.19. Oops. Oh, that's something's definitely off there. Hang on, let me just try that again. All right. 4.2 minus 3.74, better, divided by 0.19. Yeah, yeah. So 2.42. Relative to its population, which one is smaller? Remember, this is Chico, and this is Emma. And Chico has a smaller z-score, so actually that makes Chico the smaller of the two, relatively. All right. Number 18. Find the z. Oh, I got to read the problem. The year Austin graduated college, he got a job as an entry-level software engineer working for a firm in the United States. His starting salary is $68,000 a year. For the year Austin graduated, the starting salaries of all entry-level software engineers in the United States had a mean of $73,000 and a standard deviation of $2,100. Find a z-score. Okay. So z is going to be his salary, 68,000, minus the mean, 73,000, divided by 2,100. So I'm getting about negative 2.38 as the z-score. Remember, anything less than -2 is considered unusually low. So Austin's starting salary was, now be careful here, this is a positive 2.38, but it is below the mean because it's negative. So even though we got a negative z-score, they're still looking for a positive answer because they want to know how many standard deviations it is, and then we have to select below in this case because it's a negative. All right, so
Will it always be positive then, if even if it's negative?
yes,
And
just like it is here. Yeah,
will it be positive if it's positive?
yes. And
Okay.
then you would say above.
Okay, thank you.
Yep. Good question. All right, let's get this data. These are heights of students in a seminar. And we want to know percentage of students who are shorter than 61 inches. So let's get our list going on here. I have a feeling a commercial is going to creep up soon, but we'll see. 62, 68. All right, so I'm going to sort this. Second quit. Sort ascending order. Second one. Now your calculator, the list itself may not come up like it's showing on mine. Um, so you would just need to go into edit, stat edit, and you'd be able to see it there. I'm going to write these down. And they want to know those who are shorter than 61 inches. There's a total of 8 here. Okay. So shorter than 61 inches is right here. There's only 2 of them. So that means it's going to be 2 out of the 8. So the answer is 25%. All right. Let's take a look at box and whisker plots. And I think we got everything. Yeah. All right. Which city had noon temperatures with a larger IQR? That is going to be, you can see the IQR is represented by the box. So which one has the bigger box here? I'd say that one for sure is way longer. So this is going to be city B. Which city had the highest noon temperature? The highest noon temperature. That's going to be this one way over here. That has the highest noon temperature. That is definitely city A. Which city had more noon temperatures above 80 degrees Fahrenheit? Well, it looks like they both did. Looks like let's use another color. It looks like they exactly tied. So they both had the exact same number. Huh, wrong blue. And which city had a larger median noon temperature? That's going to be city A again. Now, this one here represents the median here and here. And which one is larger? That's definitely city A.
Professor Ryan,
Mhm.
looking at the which city had more noon temperatures above 80,
Uh-huh.
and our answer as it stands is they both have the same number. But aren't
Correct.
those, aren't those other temperatures, like the temperatures of like 81, 82, 83, 45, aren't those also above 80?
They are, but um, no, but they're both their third quartile ends at the exact same spot.
Ah, okay,
Yeah,
got you.
yeah,
Thank
I
you.
know, and I appreciate you asking.
Sure, thank you. That makes sense.
Good. All right, let us move on and make our own box and whisker plot. Okay, so first off, below are numbers of hours that a sample of 20 recent college students reported working last week. All right, so let's take a few minutes. We've quite a bit. This one's going to take the longest of all of them. And I'm going to put this data into my list. All right. All right. I'm going to go ahead and quit and I'm going to sort that real quick. All right, so let's clear that. Okay, now that we have that, now we're going to run one var stats to get our, and let me set this up over here like this. So we're going to have our minimum, our first quartile, our median, our third quartile, and our maximum. So here we go, stat, calculate, one var stats. And of course, it's commercial. Yay, that one went fast. And here is my 5-number summary. So here we have 15, 35, 40.5, 46, and 57. All right, now we need to explore our interquartile range, or IQR. If you remember, that is Q sub 3 minus Q sub 1, because we're looking for outliers now. And that is going to be 46 minus 35, which is 11. Now my lower fence, or lower boundary is what ALEKS calls it, same thing, is Q sub 1 minus 1.5 times the IQR. So I'm getting that my lower fence is 18.5. My upper fence and of course you can have these formulas on your note card during your test. $62.5. All right, so now I'm going to go back into my list. Do we have any values less than 18.5? Yes, we do. We have 2 of them. So outliers. So far, we have 15 and 16 are outliers, which means this one's out. Our next data point that is above 18.5 is 23. Let's see if we have any on the other end. Do we have any numbers more than 62.5? We do not. So we just have the 2 outliers here. So let's put it all together into a badly drawn graph. Here we go. First, let's start with the outliers, the 15 and the 16. So let's stick with the purple theme here. 15 and 16. We put a little asterisk. Let's do those a little better. 15 and 16. Then next up, we have 23. So 23 is here. We have 35, which is here. We have 40.5, so that's about here. We have 46. And we have 57. All right, let's see if I can draw this. Ooh, that's terribly drawn. You get to use a computer when you do it, so you just literally drag and drop. And that is going to be our practice test.